Welcome back. We are now on change in momentum. Remember, as per examination guideline, the change in momentum will be delta P, but we have got 3 points that you need to take into consideration. Momentum can change when velocity increases. That's the first point. Again, momentum can change when velocity decreases, the brakes are applied. And then the last one, momentum can change when velocity changes direction. Direction means that now there's a wall, the ball is heading towards the wall, strikes the wall and come back. So the one to the right, to the left. So that is the 3 scenarios that you must take into consideration in this case. So in simple terms, delta P, which is change in momentum, will be, as I said, PF minus PI. And what is P is your MV, therefore we'll have MVF minus MVI. That's the simplest way of expressing change in momentum. But some people have got their own way of dealing with this. Some, they can use maths and manipulate this and say, manipulate this one and say, therefore M is the common factor, therefore delta P can also be expressed as M into VF minus VI. So if you understand it, no problem, you can do it that way, but the easiest one will be this. Now, before we do calculations and examples in this one of change in momentum, there is another part as well where now we talk about the graphical representation of delta P. Graphical representation of change in momentum. Graphical representation of the change in momentum. Change in momentum. Now, the easiest way in this case, I'll say, these are the important notes if you want to make this section easy. First, make sure that you start with a PI. Start with initial momentum, PI. Secondly, follow with PF, but ensure that both start at the same point. Very important is that one, at the same point. If they don't start at the same point, we'll become confused. They have to start at the same point. Then, to find the delta P will be the line now, straight line drawn from a head of in this case initial PI to the head of PF. Then you are done. That will be the easiest way. Let's say, for example, one example here, initial momentum, it's 10 kilogram to the right, 10 kilogram meters per second to the right. And then the final momentum, the velocity was increased, that's the ease. Then the final momentum was 18 kilogram meters per second to the same right, to the right again. Therefore, the final momentum, we say we start from the end of the initial to the end, the head of the final. This will be your delta P. Simple as that. Therefore, it means that the change in momentum now will be so many, let's say like in this case 8 kilogram meters per second, then in the direction of the 18 kilogram. That's the case. So therefore delta P will be defined by this one of 18 PF minus PI, which is the same as 8 kilogram meters per second to the right. Make it easy. That's how we deal with this one. You can take various examples and then you will see how easy it is to deal with this one. Let's take one where now the momentum changes direction. Let's say, for example, another example 2, to say initial momentum, let's say it's 10 in this case. I've got 10 kilogram meters per second to the right, and then the final momentum, in this case now the ball hits the wall and come back, and then the final momentum now is 4 kilogram meters per second, now in opposite direction. Now we say start from the head of the initial to the final, meaning that now this is the head of the initial and then you head into the direction of the final. Therefore this will be my delta P. Very easy. Therefore it means that now delta P will be what? 14 kilogram meters per second. 14 kilogram meters per second to the left. So that's how it is. But if you want to calculate, then this will be the idea. You will say delta P equals to PF minus PI. Be careful, you choose one direction as positive. Let's say positive is to the right. Now if positive is to the right, therefore 10 kilogram will be positive, which is the initial, and then the final will be negative. Then we'll have negative 4, negative 10. Therefore it's negative 14, but because it's negative 14 means that it's in the opposite direction, therefore it will be the same as 14 kilogram meters per second to the left. Easy. I think if you can get to this and then just follow as I say, then this delta P graphical representation of it will never be a problem for you. So I hope you understand it and you can solve any other problem related, whether is the third scenario where now the velocity decreases, it will be the same. So thanks a lot. Until the next stop. Bye.